Hello everyone. I'd like to share of my current 70 project. So the topic is about brightness induction. So this study is mainly based on a study from Vincent from our department, and in the left of the figure, you can see so in the upper row, so they call it control condition. So it means when you change the inner and outer row circle, you will not change the perception of people. But in the lower row, when the probing region is gray, then when you change the luminance of inner and outer circle, then you will see a luminance change for your perception. And then from this study, they found in V2, especially in the, can you see my mouse or not?
Yes, we can see it.
Okay, I'm sorry. So in this row, it's like in the induction condition, which means in this part, when you change luminance, your perception also changes. And they found in V2, they found this anti-phase shape relationship between the change of luminance and also change of your perception. And we want to do a follow-up study based on their study. And this is what the stimulus we are using for. So then every time we start from the whole gray, full screen gray, and then the luminance of this part, we call it background, will change either to black or either to white. And then so we leave the center of the stimulus unchanged. And maybe sometimes you will notice when you change to black, maybe the perception of the center one will be a bit brighter than the one at the right side. And this is what we use for our study. And to investigate this, we decide to divide the stimulus into 3 parts. So in the center of the stimulus, we call it center, and also the edge of the square, we call it edge, and also the background. We want to keep the ROI a bit small because we want to avoid the leakage from the contrast between the edge, so we keep the center a bit small, and the background is purely where the luminance change. And if we can see some opposite response based on the perception and the luminance change, then we might find something we are interested in. And to do this, we have the PRF mapping. And this is one of the eccentricity of the one of the PRF. And in the center, the circle in the lower part is where the center of the stimulus. And in the upper part here, so it's where the edge and the background ROI. And this center one is stand for the edge, and I make it all together. Here are some activations for the 2 conditions. I have one condition is increase the luminance, and another one is decrease the luminance of the background. And this is beta value from the GLM. And so you can relatively say, so when you increase the luminance, the background area, so they have those positive both signal change, and when you decrease the luminance, then you have those negative both signal change. And in the center area, so you can see some positive and negative both signal change, but for the luminance down condition, so you say those positive, mainly positive both signal change. And to make it maybe more clear, so when I contrast the two conditions, in the center of the area, you mainly see the negative both signal changes. So if I want to put it so directly, so when you decrease the luminance, then the perception for your center area will be more brighter compared to the one when you increase luminance, then which means the both signal change will be have opposite direction. And also you can verify in the background region. So background is because you contrast by the luminance increase to luminance decrease, then you should expect a positive change in the background area. But if you say a negative both signal change direction, maybe it also means your perception changed. So I think in this project, the PRF mapping is very important. For now, I have 3 or 4 rounds for each participant to get relatively good PRF mapping. But sometimes I was wondering whether there are other ways to have a better PRF mapping. So some people will suggest I use the same design matrix and then keep running it multiple times and average and then fit into the PRF model. And other person also say I should randomize the design matrix. So I think for here, I would also like to ask some advice from all of you. And also I have, because this project will also want to get a layer profile for the center and the background and the edge regions. But the background and edge ROI is very small. But I'm wondering whether it's still possible or it's valid to get some layer or layer mask for those kind of ROI. And this one is just a few. I have several runs of PRF mapping, and so each run it relatively give you decent PRF mapping, but there's still some differences. And I think I really need some advice for this. Otherwise, because if I do not have PRF mapping for this person, so the later analysis will be run out. So I think it's also for the polar angle from run by run and the average of all the runs. There's some difference, but I don't really know which kind of difference is good or bad. So I think that's it for my presentation.
Thank you.
Thank you, Yawen. So, anyone wants to say something?
Maybe I can comment on the second question of the slide number 10 or so. Is it possible to get a layer profile? I think absolutely it should be possible, like especially for, like you say you have a small region, but I think as soon as you have 10 by 10 voxels, usually you are already directly in the physiological noise dominated regime. So then making the ROI even bigger doesn't even give you anything. And in fact, like for the motor cortex study that I showed, you could only have a kind of ROI that was as thick as wide as the cortical thickness itself. So I think even if your ROI is small, you should be able to get reliable layer profiles from it. That's more about is it possible, how you do it, and then what the details are, how you define it, of course, is a whole different question. And this obviously depends on the PRF results, right? You need to know what is the center and what is the edge. And especially when it's small, then you need to have reliable PRF. where I'm afraid I cannot really comment on how to improve that, or where this variability is coming from in the PRF or the eccentricity.
I see. Thank you. And I have, because maybe I can. So if is it possible if I only have this small, so if I only have this voxel, the center one, if this is only I get from the ROI, it's still possible to because
you mean if you only have one voxel as your ROI?
Yes.
But I mean on the surface, right? So on the surface,
yes.
You are selecting vertices, and from the vertices you need to transform to the volume space, like to be able to do the kind of layering that we are doing. It uses the volumes primarily.
Yes.
And this mapping, of course, can be done from the vertex coordinates to the back to the volume. And if you select only one vertex, it will end up in the middle of one voxel, right? And there, if it is on the mid-gray method, let's say, this can be grown outside perpendicularly to meet the inner and outer gray matter borders, and then it will become your region of interest with some layers in it. But of course, like if it is only like 5 voxels that you get from your ROI, I don't know, like it might be a bit too small for doing like something meaningful there.
It depends on your effect size and everything. Like Logan showed earlier that he could see like every vertex at every depth individually and could see how consistent those are, even in the early and late, like looking at tiny differences in the HRF. I'm not sure how many, like how long scans those were and how many averages, but if they can, then why shouldn't you?
Yeah, but I think the answer to the question is yes, you can do layered profiles.
Okay.
And there are other details, of course, related to what you will see at and how do you interpret. Yeah, I also the PRF part. Well, if you want to get better PRF maps, the easiest thing would be acquiring more data, I guess.
Okay.
But probably it's not an option, right? To have the double the sample size for the PRF runs that you are running.
Yes, because I already have 2 sessions, and one is 1 hour, another is 2 hours.
And do you know whether you are getting a specifically noisy PRF maps compared to similar studies? You can check this from the literature, right? Sometimes they share single subject maps together with the publication, so you can see whether like your situation is special or is it just a normal expected kind of noisy pattern.
I see. Okay. Yes. I think this participant, I think is relatively good one.
Yeah, I guess so there might be participant related significant differences too. Yes. So you can of course increase your participant size, right? If possible. These days, I don't know.
But did I understand it correctly that when people perceive like the center as being more bright, then the bold is actually less strong as opposed to when they perceive it not as bright?
Because they are both compared to the initial gray. So if it's perceived to be bright, then it should be have larger bold signal change.
It does. Okay.
Yes.
Gotcha.
Yeah, I have a few comments. I'm not sure whether I should say it now or when.
Say it, Minja.
Okay.
We have a few more minutes.
One about the multiple runs. I think the best practice probably is to have a different design matrix and do the GLM with all the runs together. So this is more powerful than just simple averaging because you can't guarantee that the same voxel is recorded in your each run because the person will move. So, well, this is, well, also, how to say, I think this is more powerful. And for your differences across different runs, I think that may be due to, let's say, the person having very tiny movements of their eyes or the adaptation of their cortices. So these are all playing in this, how to say, this effect you see. So it's kind of complicated, and I guess it's better to just have so estimate everything together in one GLM, then you get one set of data, then you extract data from that. So if you do individual run differences, there will always be differences, which is really hard to handle.
Yes. So the GIF I showed here. So each run. So and I fit it every run, but I also fit into the 4 runs all together. So because I want to make sure, so every run they don't have very bad PRF. If they have, then I can kick them out and then put all the good ones together.
Yeah.
Yes.
Yeah, and you see the eccentricity outside the fovea, it's quite consistent. The fovea is really difficult for PRF, the method, so I don't think it's a big problem because everyone has a bad fovea PRF.
Okay. Yes. Because it got my concern is because the edge ROI is very small.
Oh, yeah. That's a different question. So I was wondering, because you have a rectangle, so you have edges at your top, your bottom, your left, right, and
Yes.
this location corresponds to where?
It's around green and a bit light blue around here, around 6.
Yeah, can you tell which visual field, or is it the bottom one or the right side one? Because I thought you may have like a box on your cortex, but you only have a line. So maybe the data itself there, it's quite noisy. So that I don't know.
I see.
So I was guessing it might be bigger. Yeah. Yeah, that's it.
Okay.